hydrogen peroxide. Topic we are going to start is hydrogen peroxide, chapter hydrogen. Formula of hydrogen peroxide is H2O2. And in this formula, oxidation number of hydrogen is 2 into plus 1 plus 2x is equal to 0. It means x is equal to minus 1. Oxygen minus 1 is called peroxide. It means hydrogen peroxide H2O2 is having oxygen with minus 1 oxidation number, right? The first topic we are going to start is methods of preparation of hydrogen peroxide. First heading is methods of preparation. How to prepare hydrogen peroxide. When we talk about methods of preparation of hydrogen peroxide, first method we are going to start is from metal peroxides. Metal peroxides, whenever react with acid, we get hydrogen peroxide. That is the main product. For example, if it is barium peroxide, BaO2, plus sulphuric acid, it is acid, we get formation of barium sulfate plus hydrogen peroxide. You can complete the reaction. Barium peroxide plus carbonic acid, barium peroxide or sodium peroxide plus phosphoric acid. Complete these reactions, as these reactions can give us salt plus hydrogen peroxide. It means first method of preparation is from metal peroxides reacted with acidic medium or in acid. It is leading to the formation of hydrogen peroxide. Right? Completed. In this reaction, we get barium carbonate plus hydrogen peroxide. In next, it is going to be barium phosphate, Ba3PO4 whole thrice, twice, plus hydrogen peroxide. Then is sodium sulfate, Na2SO4 plus hydrogen peroxide. When we talk about barium peroxide and these methods, out of these, this is the best. Because phosphoric acid, H3PO4, is a preservative for hydrogen peroxide. That means a negative catalyst for decomposition of hydrogen peroxide. But in the first method, hydrogen peroxide in presence of sulfuric acid decomposed to give us water plus oxygen. It means sulfuric acid can decompose hydrogen peroxide. That's why first method is not very good method. But the last phosphate, meaning phosphoric acid, is a good acid to be used. It can give us a hydrogen peroxide with good percentage without any special decomposition due to sulfuric acid. Now, sodium peroxide plus sulfuric acid, it is used in lab preparation So during laboratory preparation, we have sodium peroxide and sodium sulfuric acid leading to sodium sulfate and H2O2. This process is named as Merck's process. It is called Merck's process for hydrogen peroxide. Sodium peroxide plus sulfuric acid. Name of the process is Merck's process. So you must know that what is Merck's process. And what is Merck's process? It is sodium peroxide reacting with sulfuric acid. Sulfuric acid used here is 20% by concentration and ice cold mixture. It is 20% ice cold mixture of sulfuric acid is used, and this reaction is used for the bleaching purpose where sodium sulfate is not causing any problem. So for bleaching purpose, we are using this reaction. Here 20% ice cold sulfuric acid is used, and this reaction is used for bleaching purpose. Right? This is the first method of preparation of hydrogen peroxide. Is it clear? In some of the books, it is written as barium peroxide dot 8H2O, that means hydrated salt, combined with phosphoric acid. Because barium peroxide is hydrated, that's why it can be written as 8H2O. Reaction will be same, answer will be same. We get barium phosphate plus hydrogen peroxide. So barium peroxide dot 8H2O means it is going to be hydrated persulfate of barium. Right? Now in this reaction, question arises, if we have sodium peroxide plus water, what will be the answer? Answer should be hydrogen peroxide plus NaOH. Two NaOH, and we get formation of sodium hydroxide and hydrogen peroxide. This reaction is not a good reaction to be used because sodium hydroxide decompose hydrogen peroxide very fast. Decompose H2O2 at a very fast rate. It means we can't use water with sodium peroxide. We can't use sulfuric acid with barium peroxide. Best acid is phosphoric acid. Carbonic acid is okay, but phosphoric acid is best. Now next method, that is manufacture of hydrogen peroxide, second method of preparation. So next we move on to the second method of preparation of hydrogen peroxide. It is by electrolysis of concentrated sulfuric acid. Second method of preparation is electrolysis of concentrated sulfuric acid. Concentrated sulfuric acid is going to decompose and leading to the formation of H positive plus HSO4 negative. These are the two ions in the solution. Concentrated sulfuric acid is having a good percentage of hydrogen sulfate ions. Now at cathode, H positive is going to gain one electron, we get H. H plus H, it is going to be H2. At anode, it is HSO4 negative minus one electron, we get HSO4, and HSO4 combined with another HSO4 and we get formation of H2S2O8, which is called Marshall's acid. This Marshall's acid is actually a peroxo disulfuric acid. peroxodisulfuric acid. It is called Marshall's acid. This peroxodisulfuric acid, it is H2S2O8 combined with water, that means diluted, to give us H2SO4 plus H2SO5. H2SO5 is called Carr's acid. It is Carr's acid, which is also called peroxomonosulfuric acid. Peroxomonosulfuric acid. This peroxomonosulfuric acid again is diluted to give us H2SO4 and hydrogen peroxide. This is how we can get formation of H2O2 by using electrolysis of concentrated sulfuric acid. It is preparation of hydrogen peroxide in large scale, and here preparation is hydrogen peroxide in commercial problems, commercial cases, and commercial preparation of H2O2 is done by this method. Here the sulfuric acid used is about 50% concentrated. The concentration of sulfuric acid used is 50% concentration of sulfuric acid. Mass percentage is 50%. Now this method is having a limitation of sulfuric acid acting as a catalyst for decomposition of H2O2, because presence of sulfuric acid is there and this can decompose this H2O2 at a very fast rate. The percentage of hydrogen peroxide formed is not going to be very large. Therefore, we have modified this formula, this method. The modification of this method is modified electrolytic method is modified electrolytic method is electrolysis of ammonium hydrogen sulfate. So now we'll start with modified method. So concentrated sulfuric acid electrolysis you have done. Now we are having modification in this method, and that modification is electrolysis of ammonium hydrogen sulfate. Ammonium hydrogen sulfate NH4 HSO4 dissociate to give us H positive plus ammonium SO4 1 negative. These are the two ions present in the solution. At cathode the reaction is exactly same. 2H positive plus 2 electrons, we get hydrogen. At anode the anion which is going to be there, that is ammonium NH4 SO4 1 negative minus 1 electron. It is NH4 SO4 plus 1 electron. It means electron is lost, oxidation taking place. This NH4 SO4 is not stable. Combined with another NH4 SO4. This is multiplied with 2 now. And we get formation of diammonium S2O8. H2S2O8 is not formed. Now it is diammonium S2O8 is formed. And this chemical, which is ammonium 2 times, sulfur 2 times, oxygen 8 times, having peroxo linkage, is now diluted with water. When we mix it with water, we get ammonium sulfate plus hydrogen peroxide. So we get formation of ammonium sulfate plus hydrogen peroxide. It means now there is no formation of sulfuric acid. We are not getting formation of sulfuric acid. We are getting ammonium sulfate, ammonium hydrogen sulfate and H2O2. Thus, hydrogen peroxide can be easily prepared without any decomposition by sulfuric acid. This method is there. In some of the books, if we write it for once, if we write it only once, so it will be like ammonium hydrogen sulfate. Balancing of a reaction is required. You can balance this reaction and we get H2O2 is formed after dilution. That is your second method of preparation of H2O2. Now, next, third method of preparation, again a manufacture, large scale preparation. That is third method of preparation of hydrogen peroxide. It is by using a reaction of ethyl anthraquinol. Compound we are going to use here is third method. It is going to be 2-ethyl anthraquinol. It is oxidation of 2-ethyl anthraquinol. Anthracene is what? Anthracene is 3 benzene rings together. This is anthracene. Anthraquinol is anthracene with 2 OH. And what is 2-ethyl anthraquinol? That is your, this compound, this carbon is numbered as 1, this is 2, and this is 2-ethyl anthraquinol. When we oxidize this chemical with aerial oxidation, air is there, from air we can have oxygen, we get formation of ethyl anthraquinone. It is formation of 2-ethyl anthraquinone plus hydrogen peroxide. It means indirectly we can say that we are oxidizing alcohol to ketone and we are reducing oxygen to hydrogen peroxide. Oxygen here is 0 and here is -1. It means oxygen is being reduced and alcohol is being oxidized. This reaction can be reversed by using reduction. Hydrogen in presence of nickel, it means the product formed is further reduced backwards and we can again treat it with oxygen. Thus, we can have hydrogen peroxide as a result. So, this method is a very important method, industrial preparation again. This third method is industrial preparation of hydrogen peroxide by using oxidation of 2-ethyl anthraquinol. It means major raw material for this reaction is going to be oxygen only. Because here hydrogen and nickel are the catalyst, nickel is catalyst, it is not to be used again and again. Hydrogen is a gas, major raw material is oxygen from air, which is cheap or without any cost we can get from air, and hydrogen gas is required for backward process. Once we purchase this chemical, we can get hydrogen peroxide, again reduction, again hydrogen peroxide, and so on. So this is all about your methods of preparation of hydrogen peroxide. We are finished with the first topic, methods of preparation of hydrogen peroxide. Right? These two chemicals you must know that one is anthracene. First is anthracene and second is anthraquinol. Anthraquinol. We can sum up these methods of preparation of hydrogen peroxide. Complete this flow chart. Hydrogen peroxide can be prepared by BaO2.8H2O plus phosphoric acid. That is first method we have done, very important. Sodium peroxide plus sulfuric acid, again hydrogen peroxide is formed. 50% concentrated sulfuric acid on electrolysis. We get hydrogen peroxide. Ammonium hydrogen sulfate. Electrolysis of ammonium hydrogen sulfate. And then we have method from ethyl anthraquinol to ethyl anthraquinol with aerial oxidation, we can get hydrogen peroxide. This method is called Merck's process. And it is laboratory preparation. Barium peroxide plus sulfuric acid can be used, and limitation of this method is sulfuric acid can decompose hydrogen peroxide formed. So these are methods of preparation of hydrogen peroxide. Diagrammatically you have learned it. Easy topic. And all these reactions are important reactions. Note it down. Next topic we'll start is concentration of hydrogen peroxide. Hydrogen peroxide formed is not pure H2O2, it is always a mixture. It is formed with water always, so we have to concentrate hydrogen peroxide. Concentration of hydrogen peroxide. A difficult task. Dangerous to concentrate because decomposition of hydrogen peroxide is explosive. How we can concentrate it? Hydrogen peroxide solution, which is very dilute, about 5% to 15% by concentration, is first cooled to low temperature and crystals of ice are separated. Water will crystallize first and we can separate crystals of ice. Carefully heat it to remove water. And concentration of hydrogen peroxide can be obtained by this careful heating is up to 30%. Then distillation under reduced pressure. Temperature less than 60 degrees Celsius is to be given. And we get about 90% pure hydrogen peroxide. If you want to have further purification, you want to have still pure hydrogen peroxide, then you have to freeze the mixture. This mixture is treated with ether and CO2, dry ice, and H2O2 is crystallized. These crystals are then melted to give pure hydrogen peroxide. This is how we can get pure hydrogen peroxide. Process is not easy or one-step process. Reason is hydrogen peroxide is very sensitive to heat. We can't boil H2O2 directly. Thus we can say, first of all, we remove some of the ice. Then we have careful evaporation of water, because water is more volatile than hydrogen peroxide. So careful evaporation of water, that means remove water. It is by evaporation. The concept here is important. Which one is more volatile? Water is going to be more volatile than hydrogen peroxide. This is important here. Whose boiling point is more, water or hydrogen peroxide? It is hydrogen peroxide is having more boiling point. That's why water can be removed by evaporation. Evaporation is conducted, careful evaporation, so that H2O2 is not going to decompose. Then we have distillation. Distillation under reduced pressure, because at normal pressure what hydrogen peroxide solution cannot be heated, it will decompose. So this is purification of hydrogen peroxide by the method called, first step, formation of ice, second step, evaporation of water, third step, distillation under reduced pressure, the fourth step is crystallization by using ice cold mixture, CO2, dry ice or ether is used for this purpose, and then we get pure H2O2. Next we are going to do is strength of hydrogen peroxide solution. Next topic we have is strength of hydrogen peroxide solution. How to calculate strength of hydrogen peroxide solution? It is industrial chemical used in several purposes like bleaching, etc. So we can say its strength is important. How to express its strength, whether its normality is important or molarity or percentage strength or volume strength or equivalent mass, all these terms numerically are important. So now we want to have strength. We want to know about the strength of hydrogen peroxide. Note it down. Two types of strength of hydrogen peroxide is expressed. One is called volume strength. And another is called percentage strength. Volume strength and percentage strength. Before we start with this strength topic, we must know that equivalent weight of hydrogen peroxide is equivalent weight of H2O2. It is going to be 34, that is molar mass, divided by 2, which is equal to 17. Why 2? Reason is O2 2 negative is converted to O2 negative. It means -1 to -2, the changes of 1 electron, and multiplied with 2 because 2 oxygen atoms are there. There is change of 2 electrons, gain of 2 electrons. Thus we can say divided by 2. So peroxide can change into oxide, or it can be peroxide can change into O2. That means 0. So -1 to 0, loss of 1 electron. There are 2 oxygen, therefore total loss is 2 electrons. Again we can say the same division number is there. Divided by 2, it is going to be 17. So equivalent mass of H2O2 is always 17, whether it is losing or gaining electrons. So it is going to be 17 equivalent mass. Now we have volume strength, and we can understand volume strength by some terms like 10 volume. When we write 10 volume hydrogen peroxide, it means 1 volume of H2O2 is going to give us 10 volume oxygen at STP. That means if we have 20 volume hydrogen peroxide, it means 1 volume of hydrogen peroxide is going to give us 20 volume of oxygen at STP. That is the meaning of volume strength. The volume strength is expressed in terms of oxygen volume. Now you can understand it by 1 milliliter of H2O2 is going to give us 10 milliliter of oxygen. And if it is 1 liter of hydrogen peroxide, it will be 20 liter of oxygen. That means volume can be milliliter, liters. If it is milliliter, this oxygen will be in milliliters. If this volume is in liter, oxygen will be in liter. That is about your volume strength. Percentage strength is when I write 10% hydrogen peroxide. That means 10 gram hydrogen peroxide in 100 ml of solution. Important here is this percentage strength is mass by volume percentage. 10% means 10 gram H2O2 in 100 ml of solution. That means another we can write it 20% hydrogen peroxide. It means 20 grams of H2O2 in 100 ml of solution. That is about your percentage strength and volume strength, how the concept is going to be there. Now we have the formula and interconversion of these strengths. If we want to talk about normality, normality is weight upon 17 into 1000 upon volume of solution. And molarity is going to be weight of hydrogen peroxide by 34 into 1000 upon volume of solution. We can say that normality and molarity are related. Normality is molarity into 2 for hydrogen peroxide. Is it clear? Molecular mass of H2O2 is 34. Equivalent mass is 17. Normality and molarity formulas must be clear to you. The numericals of hydrogen peroxide can be solved by the formulas.
आ गया उनका मैंने कर दिया Ma'am,
Yes, beta.
So, ma'am, for meeting the average balance, it would be something between us.
Just a minute, beta. Just ninth class. It is ninth class.
Yes, ma'am.
Okay. Just a minute, beta.
जो खाली हो जैसे कॉल सेंटर में
ओ ग्लव्स मेरे ले
देखिए मेरे डेस्क में कुछ बचा है
ए डेस्क
Two flow.
तो क्या है क्या ये
गुड मॉर्निंग मैम गुड आफ्टरनून